So we'll skip to the switch case block. I will simply comment this thing out. So remove this comment here. Fine. I have a switch case block here. I'll just finish it here. I'll copy this. Sorry, cut it, and we'll have it right under the outer block here. Okay, I have nested switch case as well. I'm only checking for the X in the outer switch case. You can check for any variable. So it is as if I'm checking the variable X, comparing the variable X with the multiple values possible, and wherever I have a match, I will simply execute few statements. That is the point of switch case. So I have switch X if X in case is 20. So you write case 20. Have a space here. This is not a semicolon, this is a colon. Okay. Then you go to the execution part. Here what I have done is I have nested a switch case block in here under this case. So switch case, first switch case, this is the second switch case. So I have written this in this way: outer switch case and inner switch case, the first switch case. So after switching or say testing for X, if it is equal to 20, and if it is true, if X equals to 20, all the statements within this case are going to be executed. Let's assume that X is 20. What happens is it will again go to this switch case structure and it will check for Y and find whether Y is equal to 10. And if it is 10, it's going to execute this statement, or else this statement when if it is equal to 20, or this statement if it is equal to 30. And if Y doesn't match any of the values present in the cases here, three cases 10, 20 and 30, it will go to the default case where there is no value. No value is required in default case. In such a case, you don't know what value Y has, and therefore you simply write a statement or give a warning message. I have given a pretty dumb message in here saying that you have reached the default case. The working of the outer switch case is also the same as if this switch case. After this is executed, say you have not matched the value of X. Say the value of X did not match the case 20. In that case, it will go to the second case and we'll check whether the value of X is equal to 10. And if it is equal to 10, it will execute these statements which are following this case or embedded or which are written under this case. These are the statements. Again, this is a switch case block, nested switch case block. This is the second switch case block. I have three cases in here, the same thing, 10, 20 and 30, and a default case. So if X is not equal to 20 and if it is equal to 10, this is going to be carried out. And if the X is not equal to 20 either, if X is not also equal to, say if X is, okay fine, now let us say X is not equal to 10 or 20, then it will go to the case 30 where I have no switch case embedded or nested in here. It is a simple statement. It will simply write yuppie, and if we fail to find the value of X within 10, 20 and 30, the switch case structure will reach the default case, in which case you have this message: you have reached the outer default. In order to make a difference between the default cases present here, I have written outer default, second default and first default. So let us try this out and see what are the outputs by changing the values of X, Y and Z. So since X is 10, let us directly run it. You have an output: I am Y and my value is 20. Why is this happening? Because now the first case fails because X is not equal to 20. The second case succeeds, it will skip the whole block here, and the second case succeeds, and this happens to be true because X is equal to 10, and it will simply check Z, the value of Z, which say the value of Z is 20, right? So it will skip this case because that is not 10. It will go to case 20 and print I am Y and my value is the value of Z, which is true, correct. But here instead of Y you should have written Z. Now I'm going to change it first. Okay, now I'm going to run it again. So I have to Z. So this is the output. Okay, now let us simply remove this break statement, which is clearly visible everywhere in the switch case structure. What is this thing and what is this important? To not know its importance, we'll simply remove, say, comment it out. That's better. Okay, I commented it out. Now let us see and try the same thing. Now it's giving me an error. The error is control cannot fall through from one case label to another. So this is the error you get when you remove the break. So it is very important in C sharp. Mind you, this language has this new feature which will show you an error if you don't write a break statement after every case statement. That is, these are the statements which need to be executed, and after you complete all the statements which needs to be executed, you simply have to write a break statement. That is because in previous languages you had a problem of continuously uh, uh, carrying out all the statements after one case succeeds. Say for example, in C language you had this problem. Suppose y in here, this switch equals 20, right? It is not 10, so it is going to skip. There's no problem. But if it is equal to 20, fine. This case is going to happen. So these are the statements which are going to be executed. In the previous languages such as C, if you don't write a break statement in here, what used to happen is the control used to continuously go through all the cases and do all the jobs given in each case. So that is undesirable. So in that case, what they wanted is you need to break as soon as the case is complete. So from there, this structure evolved, and the break statement or the break keyword is still there. And this is an example of switch case and nested switch case also, because in the cases I have nested the switch. Let us see what this blue thing is saying. Yeah, I have a break. Take it out, right? Okay, fine. Now it is fine. Working. Now let us change the values of x to be, say, 20. Okay, now let us run it again. I'm y and my value is 30. So what is happening is, because my x is 20, y is 30, z is 20. Let's go down. X is 20, right? This is what we did. So this case is going to happen. Again, it's going to check y. The value of y is 30. So this is going to happen, and it's going to break all the other things. In case we have the value of x to be, say, 50, which is not either 10, 20 or 30 as we have written in the cases, it must reach this outer default case, because the first switch case tests for x. I should get an you have reached the outer default. Yes, exactly, that's what we wanted. Now suppose we have a get back to, say, 10, and say the y value is, say, 50. It should reach which block? Can you guess? Yeah, exactly, because we are testing the value of x is 10, and so the first case will be skipped. This case will be skipped. It will go to the second case. Yes, this case. In this case, we're not testing for y, we're testing for z. It'll give the z value and simply skip. So there's no change will happen. So we have, in order to see that thing happening, that is to make the inner default cases, to reach the inner default cases, we have to do one thing, that is change the value of x to 20, so that this matches exactly the first case. Now we run this. I have reached the first default case that happened because this case is true. It got inside. The y value of y is 50, I think. Yeah, yes, 50. No 50 is there in here, so it will reach the default case. The same is true for all the other default statements. It's going to happen in the same way. So there are some few statements which I would like to revisit. So these are the things. So writing like this is a good practice. Writing like this, that means each case has a break at last, and each case begins with a curly brace, ends with a curly brace. But this is not compulsory, but this is a good practice, because this will ensure that you have a outline of the case. And you may also write like this. There's no problem. You can write anyway. This is also possible, and this is also possible, and there is no limit, as in if else you have a limit of writing single statement without braces. In switch case, you can write any number of statements